So, what is light?
So light is produced like from its sources, which can be a variety of methods. For example, chemical reactions.
So, an example would be combustion, such as adding oxygen would result in something like a fire, for example.
There's also nuclear reactions, such as fusion, which is what powers our sun, and then fission, which is used in nuclear bombs. There's also electricity as well, which can just produce light through, of course, through other methods, like of course the chemical reactions or maybe through nuclear reactions are then sourced by maybe electrical energy.
So, what else is light? It can be identified as an electromagnetic wave. These waves have different wavelengths, which forms different colors, such as red, blue, six colors.
Red is produced with a wavelength of 600 nanometers, blue with a wavelength of 400 nanometers, and green with about somewhere in the middle, maybe around 500 nanometers or it's around there.
Okay, onto the particles.
So light also acts like particles, and light particles or quanta are generally known as photons, right? And that is essentially like the nature which is used to describe how you can see many things using light, right? Because the photons get absorbed by your retina, which is in your pupil, which is eventually what forms the picture. After the photon actually gets absorbed by the retina, that information actually disappears, showing that light is not actually conserved, and there can be different amounts of light or different numbers of photons in the universe at any given point in time. Light's also a boson, which means it has integer spin, showing that it's actually not a massive particle. In fact, it's actually an energy-carrying particle, which is true.